name is Rebecca Choate, and today we'll be going over the basic derivative as applied to physics. So first we'll go over what a derivative is in the first place. So you take a random coefficient, multiply that by a variable to a random exponent, and then you take your exponent and multiply that by your coefficient, giving you 12, and then you subtract 1 from your exponent, so 12x squared. And then you can continue to do that, so that's the first derivative. Second derivative would be 24x, and so on and so forth. So derivatives give us relationships between different equations. So in our first example with physics, you can compare a position equation to a velocity equation to an acceleration equation. So we're going to say Brian is running a 100-meter dash. So based off of his positioning, you can come up with the equation 2x squared plus 3x. So you can plug in 3 for your time, 3 seconds. He will be 18 meters plus 9 meters, 27 meters into his 100-meter dash. So then you can take the derivative of this initial equation. So 2 times 2, 4, subtract 1, x, plus 1 times 3, 3, subtract 1, 0, 1. So 4x plus 3. And then you can plug in 3 again, making it 12 plus 3, or 15 meters per second. So you can tell based off of the first position equation how fast and what direction he will be going at 3 seconds. So 15 meters per second in a positive direction. So then you can take the velocity equation and you can take the derivative again and get the acceleration equation. So 1 times 4, 4, subtract 1, so it's 0, so x is 1, and then 3 would cancel it out. So your acceleration all the way through for Brian is 100-meter dash would be 4 meters per second squared. So these relationships are all over physics. For example, the relationships like force and potential energy. So potential energy equals negative the integral of force, which gives you the antiderivative of force, and vice versa. So if you want to find force, you can do the derivative of potential energy. So there are lots of different relationships like this inside of physics and inside of calculus, and engineers use them every single day to make our world function the way that it does. And I will, in the future, because I'm planning on mechanical engineering majoring in the fall, I will be using these as well whenever I graduate in 4 years to help our future evolve. Thank you.